Hi guys, welcome back. We are on lesson 58. We are talking about lines of symmetry and functions, which are awesome. You're going to be dealing with a lot of functions next year when we start algebra. So getting used to hearing that word and what they are is going to be a great start. First things first, we're going to talk about lines of symmetry. Lines of symmetry. Now, before I go writing down notes, which you should also be copying down, got to sharpen the pencil. We're going to talk about, this is a heart, right? So the lines of symmetry, the way that this works is, how can I fold this heart to make things symmetrical? Well, the obvious one would be right in the center. If I fold that right in the center, you see now that they are the same on both sides, right? So that would be called a line of symmetry. Now, if I fold it in the center this way, you can see that those are not the same. This side is the right, and this is the those are the official terms. So we have the bulky part up here and the pointy part down here. Those are not the same. So the lines of symmetry, this would not be a line of symmetry. Okay, so let's talk about how that applies for some of these examples here. What we have is example. I lost my place. Example number 1. It says sketch a regular quadrilateral. Quadrilateral meaning 4, right? And so it's a shape that has 4 sides. A regular means that it's the same on all 4 sides. Basically, they wanted you to do a square. Okay, so I'm gonna do a square here. And that looks about even, right? Hopefully. Okay, and then it says show all the lines of symmetry here. All the lines of symmetry. So we, just like my heart example, if we fold it in half like this, we would absolutely get those same halves, right? If we fold it in half like this, that would work, right? We would get, now, we would get the same on either side, right? If we, I can't tell which camera to use, it would get the same on the top and the bottom. Okay, the other ones that you may not think of straight away are, if we fold along this dashed line here, we would get 2 triangles that are the same. Now, this would not work if it was a rectangle. Let me show you. If we have a rectangle like this, when we fold it, it's gonna be like wonky looking. It's gonna have a peak here. I can't do this right. It's gonna be like this, right? That was terrible. So that the diagonal ones only work when it's a square. Okay, messing up my paper here. Oh man, progress not perfection, kids. Okay, so when we do that one diagonal, we can also do the other. Now, if we think about this, we can't draw a line of symmetry like, say, right here, because then it wouldn't be the same on either side. It wouldn't be equal. So those are basically the lines of symmetry. Those are going to be the only ones for your regular quadrilateral. So it's something to think about. Okay, there is an activity here if you'd like to do that, just to kind of get a good idea. In the meantime, we're also going to talk about functions. Functions are a machine where we put something in, and we call the input, and we get our function here, and we get something out, our output. Okay, so for right now, our next example, we're gonna stick pretty basic until we get into some more algebra next year. But for right now, here's a good example that it has. Find the missing number, and it's drawn out like this: 3, 5, 7, 10, and then we have some sort of function here. We don't know what it is. In the book that says function. Bam. And then we get 9, 15, and then this is the one we need to figure out, and 30. Okay, so what it's saying is we put 3, this is our input, this is our output. When we put 3 into our function, we get 9 out. When we put 5 into our function, we get 15 out. When we put 7 into our function, we get something, but we're not sure. 10 into our function, we get 30 out. Looking at this, we can see that there's a pattern. I bet our function is that we multiply things by 3. Our 3 times 3 would give us 9. 3 times 5 would give us 15. 10 times 3 would give us 30. So 7 times 3 would give us 21. That's, for right now, that's about how you would find your functions. Okay, so now you're gonna do your practice problems. Let me get this in the camera for you. Here are your practice problems here. Oh, that says 3, 4. Okay, so we are going to do those practice problems. Go ahead and pause the video, do those practice problems, come on back, and we will make sure you got them right. All right, you guys. So for A, it tells us to do the lines of symmetry on this, or draw a rectangle and copy this rectangle on your paper and show its lines of symmetry. So we know that there's going to be one right along here. You can do a dashed line or a solid line. It doesn't matter either way. Then there's going to be another one right along here, right? But like I said before, we are not able to do those diagonals. So those are our only 2 lines of symmetry. Now I'm going to skip B for just a second because I want to use graph paper for that one. We're going to talk about these functions that I've drawn out. This is C and D. 4 to 20, 3 to 15, 9 to 45. Looking at that, I see a pattern. Looks like we're multiplying by 5. 4 times 5 is 20. 3 times 5 is 15. 9 times 5 is 45. 7 times 5 is 35. So that should be your answer. Now we've got this function. We go 0, 4, 3, 7, 5, 9. In this case, it actually looks like we're adding. 0 plus 4 would give us 4. 3 plus 4 would give us 7. 5 plus 4 would give us 9. So 1 plus 4 would give us 5. So that should be your answer there. All right, so let's talk about B. Now B was a little tricky. It said the y-axis, and remember this is your y-axis, is, get that out of the way, your y-axis, now I lost my train of thought, is the line of symmetry for a triangle. The coordinates of the 2 vertices are 0, 1, and 3, 4. So we go over 0, up 1, over 0, up 1. That's your first one. And then over 3, up 4. Over 1, 2, 3, up 1, 2, 3, 4. Now, the y-axis is our line of symmetry. Words are hard today, I don't know. Our line of symmetry. So if we have a triangle that looks like this, the line of symmetry is always down the center, and that's really the only line of symmetry that we have. So this needs to be our line of symmetry, which means that whatever happens on this side has to be copied over to the other side. Notice how it's going to be along this same one, and it's going to be 3 over. Do you see that? So we went 3 from our y-axis, 3 from our y-axis here, okay? Which means that this point is going to be over 1, 2, 3. So that's going to be -3 because it's in the negative direction, up 4. So for B, your answer should be -3, 4. All right, guys, if you have any questions, let me know. Otherwise, good work, and we'll see you next time.